20 minutes from now, your own Claude will be calling a server you built, not a demo you watched, a real model context protocol server running on your machine with tools the model selects reliably, a resource, and a prompt worth publishing. That's the deal for part 2 of the MCP Blueprint. And one guarantee before we start, because this channel earns trust the hard way. Every line of code in this video actually ran in order before filming. The tool calls you'll see return the results you'll see. Nothing here is pseudocode hoping to compile. What we're building, a team notes server, 2 tools, one to save a note, one to search them, a resource that serves any note's full content by ID, and a prompt that drafts a weekly summary. It's deliberately humble because the point isn't the notes. The point is that this little server exercises every skill that matters: tool description craft, schema design, the tool versus resource boundary, transport choice, and the logging trap that breaks half of all first servers. Swap the notes logic for your issue tracker or your test data later. The blueprint stays identical. One honest note on timing in this series tradition. The official Python SDK is mid-transition as I make this. Version 2 entered beta days ago, tracking the newest spec release candidate. Version 1 remains the stable line, and it's what every host you'll test against runs today. So we build on stable version 1, we pin it properly so nothing surprises us, and near the end, a full chapter walks the version 2 changes, so your server is ready for the future on the day it arrives. Current, honest, and dated. Let's set up. Chapter 2, Setup and the pin that matters. You need a recent Python and one package, the official MCP SDK with the command line extras. Install it with an upper bound below version 2. On screen, the exact line. Why the bound? Because the package's next stable major is the reworked version 2, and when it lands, an unpinned install could silently jump majors and break your imports. The SDK maintainers themselves recommend the bound until you've migrated deliberately. 1 line of discipline now, 0 surprise breakage later. That's the whole setup. No scaffolding tools, no config files, no accounts. The skeleton is 1 file. Import FastMCP from the SDK. Create the server object with a name. Ours is team notes, and that name is what hosts will display. At the bottom, the run call, which defaults to standard I/O transport, exactly what local hosts expect. Between those 2 lines is where everything else in this video lives. 15 lines from empty file to valid server. The protocol machinery, the JSON RPC wire format, the handshake, the capability declarations. The SDK generates all of it. Your job is the part the SDK cannot do, deciding what to expose and describing it well. 2 environment notes before code. Package Manager, the modern Python tooling UV makes this cleanest. 1 command creates the project, 1 adds the dependency. Plain pip works identically if that's your world. Windows and PowerShell users, this all works natively, no shell gymnastics required. And keep the project boring: 1 folder, 1 server file, 1 requirements entry. Resist the scaffold urge. Servers that start as 1 honest file get understood, reviewed, and extended. Servers that start as frameworks get abandoned. You can always grow structure later, when a second file earns its existence. Chapter 3, the first tool and the trick that eliminates half the boilerplate you feared. Write a plain Python function. Add type hints. Title is a string, body is a string, tags is an optional list of strings. Give it a docstring. Then put the tool decorator above it, add mcp.tool, and note the parentheses because they matter and we'll come back to them. That's it. No JSON schema written by hand. The SDK reads your type hints and generates the schema. It reads your docstring and publishes it as the tool's description. Idiomatic Python in, spec-compliant protocol out. Now the parentheses, because this is the most copy-pasted gotcha in the ecosystem. There are 2 FastMCP flavors in the wild. The one inside the official SDK, which we're using, expects the decorator called with parentheses. A popular standalone package with the same name accepts it bare. Tutorials mix them freely, and the error message when you guess wrong is unhelpful. A rule for this series: official SDK, parentheses on every time. Add the second tool the same way, search notes with a query and an optional tag filter. 2 tools, maybe 30 lines, and the server is already worth connecting. Walk the real function once top to bottom because every line teaches. The decorator registers it. the signature, title string, body string, tags optional list defaulting to none. From those hints alone, the SDK derives which fields are required and which aren't. The docstring will dissect it properly in the craft chapter. The body builds the note, stamps a timestamp, stores it, and returns the dictionary, which becomes the tool result. And one line logs to standard error, not standard output. That distinction gets its own chapter, because it breaks more first servers than everything else combined. And walk search notes too, because retrieval deserves the same care as creation. Lowercase the query once, match against title and body. Apply the tag filter only when a tag was given. That's what the optional parameter is for. Sort newest first, because recent notes answer most questions. And when nothing matches, return the honest empty list, no exception, no apology text, just an empty result the model can gracefully report. Boring, explicit retrieval logic. The model supplies the intelligence, your function supplies the reliability. That division is the whole art of tool design. Chapter 4, see it work because payoff early beats payoff late. Route 1, the MCP Inspector, the official debugging interface. One command launches your server under it and you get a browser panel showing every tool, its generated schema, and a form to call it live. Watch, add note, execute. Watch search notes find what you saved. When something misbehaves later, this is where you look first. It shows you exactly what the protocol sees, which is not always what you think you wrote. Route 2, the real one, connect it to Claude. For Claude code, one command in your terminal registers the server. Claude MCP add a name and the command that launches your file. Then open a session and ask something natural. Save a note that the budget review moved to Friday. Watch the model choose add note unprompted, fill the schema from your sentence and confirm. Then, what did we note about the budget? Watch search notes fire. That moment, the model selecting your tool correctly from plain conversation is the whole protocol working. And it worked because of the part we wrote carefully, which brings us to the craft. Route 0, actually before any host, scripted testing. The server object you created is callable from plain Python. A 5-line test script can list the tools, inspect the generated schemas, and invoke calls directly. No transport, no host, no ceremony. That's exactly how this video's server was verified before filming. Make it a habit. Every tool gets one scripted call before any host sees it. It catches type mistakes, schema surprises, and logic errors in seconds, where host-side debugging costs minutes each round trip. Test and process first, connect second. Chapter 5, the craft chapter, descriptions that select. The third law has run through this whole channel. Tool descriptions are the #1 lever. Here's what that means in code. Your docstring is the description. The model reads it to decide when to call your tool before any schema matters. A weak docstring saves a note, gives the model nothing to select on. A real one carries 4 parts. What it does, create a new team note. When to use it, when the user wants to save or record information. What input looks like, a short title, the body, optional tags. And the boundary, do not use this to search, use search notes for that. Why the boundary line? Because selection errors are symmetric. A model that can't tell your two tools apart will sometimes search when it should save, and save when it should search. Naming the neighbor tool in each description with an explicit do not is the cheapest disambiguation in the entire stack. This is exactly the pattern from the certification series developer productivity scenario, now in your own file. Write descriptions like you're briefing a new colleague who will act on them without asking follow-ups, because that is precisely what the model is. See the difference on screen. Weak version saves a note, that's the entire description. Ask the model to record that the deadline moved and it hesitates between your two tools, or worse, answers from memory without calling anything. Strong version, the 4-part docstring we wrote. Same request and selection is instant and correct because the when to use line matches the user's verb, save, record, and the boundary line eliminates the neighbor. Nothing else changed. No model upgrade, no examples, no framework. 20 words of description doing the work people buy routing layers for. That's Law 3, demonstrated in your own file. Chapter 6, Schemas and Structured Output. The input side you've seen, type hints become the schema, required versus optional falls out of your defaults, and the host validates calls against it before your function even runs. Bad arguments get rejected at the protocol layer. That's free correctness. The output side is newer and worth knowing. Annotate your return type. Ours returns a dictionary, and the SDK publishes structured results alongside the plain text, so clients can consume real data instead of parsing prose. There's an escape hatch if the classification isn't what you want, a flag on the decorator, but the default behavior is right for almost everyone. One design habit from the extraction chapter of the Summit video applied here. Schemas guarantee shape, not truth. Your type hints ensure the query is a string. They don't ensure your search logic is right. So the validation that matters lives in your function body. Handle the empty result, handle the missing ID, return honest nothing found answers instead of raising confusing errors. The model handles a clean empty list gracefully. It handles a stack trace by apologizing to your user. Design for the boring failure. The mechanics worth memorizing. Required versus optional falls out of defaults. No default means required, a default means optional, and none is a perfectly good default for genuinely optional fields. Constrain choices with literal types when an argument has a fixed menu. The schema then carries the allowed values, and the model respects menus remarkably well. Document argument meaning in the docstring, the hints carry structure, the words carry intent, and the model reads both. Small type discipline upfront buys you validated, self-documenting tools with zero extra machinery. Chapter 7, Resources done right. Part 1 gave you the test, tools do, resources provide. Our note content is a perfect resource, read-only, no side effects, addressable. The decorator takes a URI template, notes : then the note ID in braces. The function receives the ID and returns the content. Hosts can now list, address, and read any note without a tool call, and tool results can link to these URIs, so search notes can return matches that point straight at their full content. That linking pattern, tools for finding, resources for reading, is the clean division most first servers miss, and it keeps your tool results small while keeping everything reachable. One practical addition when your resources are enumerable. Alongside the template, hosts appreciate a listing, so users can browse what exists rather than guessing IDs. For our notes, that's trivial. Expose the collection, each entry pointing at its templated URI. The division of labor stays clean. The list answers what exists, the template answers give me this one, and search notes, the tool answers which ones match my question. 3 access patterns, no overlap, no confusion, and each one cheap because the boundaries were drawn before the code was written. Chapter 8, a prompt worth publishing. In the bar it must clear. Prompts are user-invoked templates. They surface as /commands and menu items. The decorator mirrors the others, a function, parameters, a docstring, returning the prompt text. Hours, weekly summary, taking a team name, returning instructions to group by tag, lead with decisions, stay under a length. The bar, a prompt earns its place when a repeated, parameterized operation exists that users would otherwise retype. If nobody would retype it weekly, it's clutter. One good prompt beats 5 decorative ones, and this server ships exactly one. Why is the weekly summary a prompt and not a tool? Run the boundary test one more time. A tool is model initiated. The model decides mid-conversation that it needs to act. A prompt is user initiated. A human picks it from a menu to start or steer a conversation. Summarize this week is a human's Friday habit, not a model's mid-task need. It has no side effects, it needs a parameter, and it benefits from being visible in the host's interface. 3 signals, all pointing the same way. When your feature is a habit someone repeats, publish the prompt. When it's an action the model needs, register the tool. Chapter 9, the logging trap, the single most common first server breakage, and it's brutal because nothing looks wrong. Here's the mechanism. On standard I/O transport, standard output is the wire. Every byte your process writes to a stdout is supposed to be protocol JSON. Now add one innocent print statement for debugging, note created. That print goes to a stdout. The host reads your debug text as a protocol message, fails to parse it, and the connection breaks or hangs. Your server crashed because you logged success. The rule, permanent and simple, on a stdo server, never print a standard output. Log to standard error, which is exactly what our server does. One extra argument on the print call, file equals sys.stderr. stderr is yours, stdout is the protocol's. And a current events footnote that makes this rule even more durable. protocol-level logging, the fancy alternative where servers log through MCP itself, is deprecated in the new release candidate. The official direction is what we just did: standard error for humans, telemetry tooling for production. The boring answer 1, it usually does. One refinement for tools that take real-time progress reporting. The SDK can inject a context object into your tool function. Just add the type parameter, and through it you report progress updates that hosts display while your tool works. Use it for the slow operations, imports, big searches, anything over a few seconds, so users see motion instead of silence. And keep the division from this chapter intact. The context object is for progress signals to the host. Your diagnostic logging still goes to standard error. Progress is protocol, logs are yours. Chapter 10, Going Remote. Everything so far ran locally over standard I/O, which is right for personal tools. The moment your teammates need this server, you switch transports, and in the SDK that's one argument, transport equals streamable-http on the run call. Your server now listens on a single HTTP endpoint, typically /MCP, speaking the current remote transport from part 1. One endpoint. If you catch yourself creating a separate events endpoint, you've drifted into the deprecated design. Stop and come back. For real deployment, the SDK also exposes the server as a standard ASGI application, one method call, which means it drops into any Python web hosting you already know: containers, serverless platforms, ordinary reverse proxies. 2 cautions before you ship it beyond your desk. First, remote means authentication. Remote servers are OAuth resource servers in the current spec, and Part 3 covers doing that properly. Don't improvise it. Second, remember the wrinkle from Part 1. A server runs with its process permissions. Locally, that meant your permissions. Remotely, it means whatever the deployment grants, which should be as little as the job requires. Least privilege isn't Part 3 foreshadowing anymore. It's your deployment checklist. Test the remote path the same disciplined way. The inspector accepts a URL, point it at your endpoint, and verify the same tool list appears over the network that appeared over the local pipe. Then register the URL with your host and run the same natural language checks from the payoff chapter. Same tools, same descriptions, same behavior, different transport. If anything differs between local and remote, you've learned something important before your teammates did, which is the entire point of testing in that order. Chapter 11, Capability Honesty, the short chapter that prevents long debugging sessions. During the handshake, your server declares what it supports: tools, resources, prompts, and whether its lists can change at runtime. The SDK declares what you actually registered, which is exactly why the framework path is safer than hand-rolling, but the design duty is still yours. If your server adds tools dynamically after connecting to a backend, say, it must send the list changed notification, or hosts will keep an outdated picture and users will swear your new tool doesn't exist. Static servers like our notes example need none of this. The rule generalizes: declare what's true, notify when it changes, and never rely on a host re-asking out of politeness. Part 1's handshake chapter, now with your name on the declarations. And you can SCE your declarations, which turns honesty into a checkable fact. The inspector's connection view shows exactly what your server claimed in the handshake, which primitives, which change notifications. Glance at it once per release. If the declarations surprise you, your mental model and your server have drifted, and hosts are living with the drift. 30 seconds of verification, and the handshake chapter of Part 1 becomes a habit instead of trivia. Chapter 12, the version 2 transition. So today's server is ready for tomorrow's SDK. What's coming from the beta released days ago? The headline rename: FastMCP becomes MCPServer, with import paths moving accordingly. If you built with decorators, that rename is most of your migration. The wire types move to their own small package, useful for gateways and proxies that want MCP's shapes without an HTTP stack. Field names go snake case throughout. And over streamable-http, the newest protocol path drops per session state entirely, every request self-describing, which means any replica behind a load balancer can answer, a genuinely better fit for modern deployment. The deprecations you already know from Part 1 carry into the SDK as obsolete markers, routes, sampling, protocol logging, each pointing at its replacement. Nothing in our server touches any of them, which was not an accident, so your action list is short. Keep the version pinned below 2 until you choose to move. When you do, read the official migration guide. It enumerates every breaking change. Expect the port of a decorator-built server like ours to be an afternoon, mostly renames. And if you publish anything that depends on the SDK, add the upper bound to your requirements today, so the stable release surprises nobody downstream. Build on stable, prepare on paper, migrate deliberately. That's how you ride an actively governed protocol. Chapter 13, the lenses in the house style. First, your stdo server connects, then the host hangs the moment a tool runs. Your code has a print statement announcing success. For suspects, the tool's schema is invalid. The print to standard output corrupted the protocol stream. The server needs the streamable transport instead, or Claude is rate limiting you. The schema would have failed at list time, not call time. The transport is fine, the connection worked. Rate limits don't hang local pipes. The print is the culprit, stdout is the wire, and the fix is one argument, file equals standard error, the most earned points in first server debugging. Second, the model keeps calling search notes when users ask it to save information. First fix, options, add few-shot examples to the system prompt, rewrite both docstrings with when to use lines and explicit do not boundaries, merge the two tools into one smart tool, or add a routing classifier. You've known this answer since the certification series, and now you know where it lives, the docstrings. Law 3, descriptions first, examples second, and the merge and the classifier remain the overbuilds they always were. Same law, new file, your file. Third lens, tutorial triage. A guide you found configures the server with transport equals SSE, and its client setup references and events endpoint. Verdict. Options, fine, that's the remote transport. Legacy, that transport was deprecated in the spec's second spring. Use streamable-http, only wrong for Python, fine elsewhere, or correct as long as authentication is added. You've been able to answer this since part 1, and now it has stakes, code you're about to run. Legacy compatibility shims still exist in frameworks, which is exactly why old tutorials still seem to work, right up until a modern host refuses the connection. Check the transport, check the date, then trust the code. Chapter 14, ship it in 3 sizes. For yourself, the server file plus the registration command. Done, it survives reboots. For your team, commit the server to the repository. Document the one install line and the one registration line in the README. Every teammate is connected in under a minute. This is the one server many clients economics from part 1, now with your name on the server. For the world, registries exist and part 1's etiquette applies in reverse. Before publishing, search for what already exists. If your server genuinely fills a gap, publish it with the description craft from the craft chapter. In a registry, your tool descriptions are also your documentation and your marketing, and a version pin in your requirements always. You know why now. One maintenance habit closes the chapter because servers live longer than videos. When you change a tool's behavior, update its docstring the same commit. The description is the interface, and a stale description misroutes models as surely as a stale signature breaks callers. Keep a tiny changelog in the README, 3 lines per release. And when you remove or rename a tool, remember the clients you cannot see. On a team, deprecate gently, add the new, mark the old, remove next cycle. The protocol gave you runtime discovery. Give your users predictable evolution in return. That's part 2 and the brick is laid. 1 file, 2 tools with descriptions that select, a resource with a clean boundary, 1 prompt that earns its slot, stderr for humans, stdout for the wire. A transport switch that's 1 argument, and a deployment story with authentication deliberately deferred, because improvised auth is how audit findings are born. Every line ran before filming, and the full source is linked below, pinned, dated, and ready to be swapped from notes to whatever your team actually needs. Part 3 finishes the series, the security blueprint, auth resource servers done properly, scopes and consent, least privilege as architecture, not aspiration, and the audit checklist for the server you just built. Subscribe and it lands the day it ships. If your Claude called your server today because of this video, that's the like button's entire job. We're building AI up from the ground, 1 blueprint at a time. I'll see you in part 3.